Hi everyone. By now you should have a pretty good understanding of how matter can be divided into pure substances, such as elements or compounds, or impure substances, which are otherwise known as mixtures. Mixtures can be further divided into homogeneous or heterogeneous mixtures. We have also looked at how atoms are the smallest particles of elements which can take part in chemical reactions and remain unchanged. Some atoms like to stick together with other atoms of the same element in twos, and they are called diatomic molecules. At a later stage, it's possible to look at how atoms can undergo chemical reactions to form molecules, which are the smallest particles of chemical compounds. In this video, we're going to have a look at how elements can be divided into metals, metalloids, and nonmetals, and then we can start looking at how all of this fits together on the periodic table. We're going to look at some properties and examples of these three different categories that elements can be divided into. In other words, the metals, the nonmetals, and at the intersection, the metalloids. We're going to do this by filling in missing words, which are also in the grey blocks if you need to refer to them. The first major difference between the metals and the nonmetals is that metals usually lose electrons, whereas nonmetals usually gain electrons. But I'll tell you more about that in another video. For now, let's talk about some of the more obvious properties, and we're going to start with the metals. So first up is the fact that metals can be hammered into sheets. If you look at a little piece of tin foil, you can see how that's been hammered into an incredibly little sheet. The word that we use to describe that is the fact that it is malleable, and I remember that by thinking of Thor's hammer or mallet. That's my way of remembering that the word malleable means that it can be hammered into sheets. It can also be drawn into long thin wires, like in a paperclip, for example, or in a piece of electrical copper wire in a piece of electrical wire. The word we use to describe the fact that it can be drawn into wires is ductile. Metals have got incredibly high melting or boiling points. That means that they have to be heated up to a very high temperature before they melt to become a liquid, or before they boil to become a gas, especially before they boil to become a gas. This is a particularly useful property in things like cooking, because it means that the pot that the food is being cooked in has got a very high melting point, which means we are able to heat the food inside the pot without melting the pot itself, because that would really be a big problem. This brings us to our next property of metals, and that is that they are good conductors of heat and electricity. So again, I can put the food inside the pot and heat the base of the pot, and in so doing, the heat is going to be transferred to the food that's busy cooking inside. In terms of electrical conductivity, that again is why we use copper in electrical wires that is able to transfer electricity from one place to another. The other property, or the next property of metals that we can look at, is the fact that they are shiny. So you only have to look at the piece of aluminium, or even the pot. You can see that the pot is so shiny to a point that it's even reflective. And the word we use to describe is that they have luster. L-U-S-T-R-E. The last little definition that we can use is that many metals, not all of them, but many metals will produce a ringing sound if hit like a bell, and that word that we use to describe that is the fact that they are sonorous. So there you go. There are some properties of metals that distinguish them from other non-metals. Now I just want to look at some examples of metals. We've got some spaces to fill in some examples here. So the examples are on the page on this side. There are a whole lot of examples there. And the idea is that we're going to fill them in the different ovals. There are obviously many, many more elements than these that we can use for these, but these are just some good examples. So the first one we're going to look at is aluminium. Aluminium is an unusual metal in that it is quite light, but that's a particularly useful thing when it comes to manufacturing of cars and aircraft and things like that. The next metal we can look at is iron. Iron is a very common metal. We find it in a lot of different places. Another one could be something like copper, like in our copper wire that we were looking at just now, or something like silver. For example, my silver rings, silver jewelry. Right, now I just want to mention this little word to you down at the bottom here that I've added on, and that is alloy. An alloy is a combination of two or more metallic elements in such a way that it generally improves the strength of either of the elements that have been combined. And to give you an example, something like our pot, you can see they've got written there stainless steel. Stainless steel is an alloy of three elements, typically an alloy of three elements that is chromium, nickel, and iron. Something else like brass is also an example of an alloy. That's a combination of copper and another element called zinc. Or something like white gold is a combination of a whole lot of different elements. So most of the metals that we encounter are actually more likely to be alloys than pure metals. Now if we have a look at non-metals have got slightly different properties, and it's quite difficult for me to find examples of non-metals in their elemental state because many of them, they are going to be found in all three states, but they are usually gases at room temperature. So it's actually quite difficult for me to find or to be able to show you examples. So like for example in air, we are breathing in oxygen. That's an example of a non-metal. Another example of a gas is one of the noble gases or inert gases. That's neon, like you would find in neon signs. And an example of something that can be a liquid at room temperature is the element called bromine, one of the halogens. And the last example, which is actually a useful example, I can show this to you as an example, is carbon in its allotrope graphite. And that's what we know typically as pencil lead. Now, it's not actually lead at all. It's not the element lead, which is a metal at all, and which is toxic. But so even though they will actually sometimes say on the leads, they will actually use the word lead, it's actually graphite, which is an allotrope of carbon. Another allotrope of carbon is diamond. So, for example, a diamond would be a good example of carbon. Now, this again, just to show you, speak about these elements. Oxygen and neon are both examples of gases. Bromine is a liquid, whereas carbon is a solid. So that's what makes the nonmetals so varied, in that they can exist in all three states or phases at room temperature, which is 25 degrees Celsius. If they are solid, like carbon, then unlike metals, they are brittle. This means that they are not malleable or ductile. Rather, I mean, you know how easy it is for your pencil to break and crumble while you're busy working. That's because that carbon is actually quite brittle. They have generally low melting or boiling points. Funnily enough, graphite is actually one of the exceptions to this. It's actually got a fairly high melting point compared to the other non-metals. But this generally means that they're going to require a fairly low heat or fairly low temperature to convert them from solids to liquids if they're melting, or liquids to gases if they're boiling. They are also fairly poor conductors of heat or electricity. So converse to the pot would be my oven mitt. So non-metals are generally used in combination to form pretty good insulators. Again, I'm going to mention that graphite is an exception to that, in that graphite is actually a good conductor of heat and electricity. The last little thing I want to mention is the fact that compared to metals, most non-metals are dull, so they do not have luster. Mostly they're going to be quite dull in color. Now let's have a look at the metalloids. So the metalloids are going to have properties that are a combination of metals and non-metals, solid non-metals specifically, and that is that they can be semiconductors of electricity. So they can conduct electricity under certain circumstances. They are very often brittle, and some of them are going to have luster. Examples of this are silicon and a substance, for example, boron. So to compare my material oven mitt, here's an example of a silicon oven mitt. And this is obviously not only made of the element silicon, but it's largely made of it. So it's going to have, in this case, the insulating properties of non-metals, but some of the properties of metals, in that it is going to be fairly flexible. Now, just to point out to you along the periodic table where we would find all of these things, this is just a little example of the periodic table. The metalloids are going to be found along the staircase of the periodic table. The exception to that is aluminium. We know aluminium is definitely a metal, but the metals are going to exist on the left-hand side of the periodic table steps, whereas the non-metals are going to exist on the right-hand side of the periodic table steps, and the metalloids will exist along the steps. So now most of the substances around us are not actually pure metals or non-metals, rather they are going to be compounds of various different substances that are more recognizable to us. So like my oven mitt, for example, is made up of a number of different types of fibers. Plastic or candle wax are going to be compounds that are made up primarily of carbon and hydrogen. They could also be including other substances like chlorine or oxygen. You also get ionic substances such as chalk, calcium carbonate, or table salt, sodium chloride.